You are given an integer array nums sorted in non-decreasing order. Return an array of squares of each number sorted in non-decreasing order. So you have been given an array, right? Initially, this array is arranged in non-decreasing order. Non-decreasing order means this array is arranged in ascending order. What you are expected to do is you need to return a new array, another array of squares of each number. So what you have to do, you have to square up each number, every single number, and then return the final squared array in ascending order. For example, let's say, so this is problem 944, I guess, 977. So we are trying to solve problem 977. Okay. So what the problem says is that you will be given an integer array in increasing order. For example, -4, -3, -1, 0, 2, 4, 6. Okay. So you can see this is arranged in ascending order. Now what you're expected to do is you have to return a new array. You have to return a new array. Right. In this new array, all the values should be squared. So what is the square of -4? 16. What is the square of 3? -3, 9. What is the square of -1? 1. What is the square of 0? 0. What is the square of 2? 4. What is the square of 4? 16. And what is the square of 6? 36. So this is the square value of each and every given integer. What you have to do is you have to store these square values in sorted order. So it should be 0, 1, 4, 9, 16, 16, 36. This should be your final output. That you have to get the square of all of the values. You have to get the square of all of the values, store them in a new array, and then arrange this array in ascending order. Arrange this array in ascending order. Right? This is the problem in hand. How can we actually solve this question? How can we actually solve this question? Now, there can be one very simple way to solve this question. Let's talk about the most simple, or you can say the brute force way. What will be the brute force way to actually solve this problem? The brute force way to solve this problem can be to create a new array, and store square of each value in the original array. Okay. Right. So what you're going to do is, let's say you're going to create a new resultant array. You're going to create a new resultant array, and you will iterate on the original array, and you will say result dot push arr at I square. Okay. Arr at I square. Right. So what's going to happen is you're going to go to each and every single value. Like you'll go to -4, and then in the new array you are going to push 16. Then you go to -3, you're going to push 9. You go to -1, then you're going to push 1, and so on. And then use an internal sort function to arrange the elements in increasing order. Okay. So most of the programming languages, what they do is they actually provide you a method called as sort. Okay. So you can do result dot sort, something like this. Okay. So in let's say languages like Java, JavaScript as well, you are going to get a function like result dot sort. Okay. What it is going to do is it is going to arrange your resultant array in ascending order automatically. Right. So let's say this is your result array. It is going to automatically arrange it in ascending order. Okay. It is going to automatically arrange it in ascending order. Now, why I'm calling this approach brute force? First thing, what's the benefit of this approach? This approach is very simple. Okay. This approach is very simple. Okay. But there's a problem. The problem here is that this sort function takes a lot of instructions to execute. Right. Later, when we will talk about time and space complexity analysis and learn more about sorting algorithms, you will realize that this sort function is taking too much time, right? And too many instructions. And we will be able to actually solve this question in lesser number of instructions altogether, right? That is why I classified this approach as a brute force approach. Is this point making sense to everyone? What I'm trying to say here? We will discuss about sort function later, but for now, I can tell you that sort function takes a lot of instructions to execute. Okay, but I would like to still code this solution so that I can show you how can you use the sort function altogether. Okay, I would like to still code this solution so that you know how to use the sort function of JavaScript. So let's at least try to code this brute force solution so that we can get a better concept around how to use this sort function. So what I'll do is I'll say let result is equals to an empty array. Let's store the value of n. Let n is equals to nums dot length. Okay, and then what we are going to do is we'll say result dot push nums at I square. Okay, so there's a exponent operator with JavaScript. We can use that. And then what we can do is we can call result dot sort. Now in JavaScript, the sort function takes a callback, right? If you by default do the sorting in JavaScript, it will not do the sorting in the required order. For example, if I actually show you, okay, let's say you have an array 5, 4, 3, 2, 1. Okay, if you do arr dot sort, right, it gives you 1, 2, 3, 4, 5. You might feel that yes, this sort function is working and it is giving us things in ascending order. But things will start becoming interesting the moment you do something like this. 10, 20. Okay. Now if you do arr dot sort, can you see now things are not in ascending order? Right? Now things are not in ascending order. Okay. Why? Because by default, what happens is the sort function arranges your data in dictionary order. So if you see with respect to dictionary order, right? If you see with respect to dictionary order, then after 1, 10 comes up. You might feel why? Why after 1, 10 is coming? Because let's say if 1 points to B, 0 points to A, and 2 points to C, 3 points to D, then can I say that initially B will come, then B A will come, then C will come, then C A will come, then D will come, and so on? Can I say this is the dictionary order? Yes or no? Right? This is the dictionary order, right? So assume that 1 is B, 0 is A, 2 is C, 3 is D, 4 is E, and so on. And if you have this data, what is the original data? The original data is B, B A, sorry, not B B A, sorry. This is D E F. So this is F E D and C B B A and CA. This is the original data. This is the original data. If you arrange this data in ascending order, or I would say alphabetical order, or we say dictionary order, then can I say the first word that should come up should be B, then BA, then C, then CA, and so on. And that's what the internal sort function of JavaScript does. It arranges your data instead of ascending order, it arranges it in dictionary order. So even if you have numbers, it is going to arrange that in dictionary order altogether, right? Other languages like Java, C++, they generally arrange this data in normal ascending order only. It's a special case with JavaScript. So if you want that your JavaScript sort function should arrange your data in ascending order, you need to pass a callback function, because that by default sort function takes a callback. This default callback tries to arrange it in ascending order. But if you do arr dot sort, right, x comma y. It takes two values because it's going to compare x comma y. And let's say you return x minus y. I believe everybody is able to understand this expression, that this is a callback method. You do AR dot sort x comma y, and you're returning x minus y. Now what's going to happen? Let's see. Can you see it arranges things in ascending order now? Why is that? Why is that? First things first. This callback method is called as a comparator method. That is, it is going to do some comparison between the two elements. Okay. Now, in JavaScript, if you subtract any two elements, let's say the two elements are numbers, the two elements are strings, right? Or one element is a number, one element is a string, anything. Every time what JavaScript does is subtraction operation leads to a number. Can I say that? Subtraction option leads to a number, right? Now, if this number comes as a negative number, if this number comes as a negative number, right? That means x is less than y. Yes or no? If this number comes as a negative number, then x is less than y. And if this number comes as a positive number, then x is greater than y. Can I say that? Right? This is when it is negative. This is when it is positive. Right? If you, let's say, pass any two values to this callback function, right? And this callback function returns a negative value, then you can say that the first argument is lesser than the second argument. And if it returns a positive value, then it says that the first argument was greater than the second argument. Can I say that? And if that's the case, what sort function does is, if this callback method returns a negative number, then if this callback returns a negative number, then it puts the smaller element first. Okay. And if it gets a positive number, then it puts the larger element first. That means if let's say I do ARR dot sort y minus x. Can you see now your array has been arranged in decreasing order? Why? Because if what is the value of y minus x? If y minus x, in y minus x, if the expression is negative, what will happen if the expression is negative? The expression is negative, that means y is smaller. But if the expression is positive, that means y is greater. Can I say that? Yes or no? If the expression here, in this case, things are just reversed, right? That if let's say x is less than y, if x is less than y, now things will become positive, right? And if x is greater than y, then this will become negative. And what happens when it becomes negative? What happens when it becomes negative? When it will become negative. If x is greater than y, this value will become negative. If this becomes negative, then x is going to be put first, right? So let me give you an example. Okay, let me give you a better example. I guess that should be more understandable. Okay, so I'll just make a quick new file, sort function demo.js. Okay, cool. Let's say I'll write the whole algorithm as well. Let ARR is equals to 3, 4, 1, 5, 10, 9. Okay, cool. Now, if you do ARR dot sort x comma y, x minus y, you do console.log ARR, and you do ARR dot sort x comma y, y minus x, and you do console.log ARR. Let's run this code. And you can see initially this is arranging the data in increasing order. This is arranging the data in decreasing order. Okay. Now let me write the algorithm for you. Okay. So what the algorithm says, that if the callback of sort function returns a negative value, if the callback of sort function returns a negative value, then not the smaller one. I guess I wrote it wrong here. One second. Not the smaller one, but the first element, not just the smaller one. The first argument is put first, and then the second argument. Okay. Else, if the callback of the sort function returns a positive value, then the second argument is put first, and then the first argument. Okay. So for example, okay. Now let's say the value of x was 4, y was 5, and the callback was x comma y as x minus y. Now can you say that 4 minus 5 is what? 4 minus 5 is negative. If 4 minus 5 is negative, then in your final output, 4 will be put first and 5 will be put next. Can I say that? Because if the callback function returns a negative value, the first argument, that is x, will be put first, and then the second argument, that is 5, right? Now, let's say x was 7, y was 3, then x comma y, x minus y. This is going to do what? 7 minus 3, that is positive. That means in your final array, what will happen is, the second argument will be put first. What is the second argument? The second argument here is 3 and then 7. Can I say that? Right? 3 and 7. And can you see, in both of the cases, what is happening? You are arranging the data in increasing order. Can I say that? Now let's take the same case with the second callback. Okay. This time the callback is y minus x. Okay, cool. Now, what is y minus x here? This is 5 minus 4. 5 minus 4. 5 minus 4 is positive. Whenever you have the value as positive, second argument is put first. What is the second argument here? Second argument is y. So this time it will become 5, 4. And here as well, 3 minus 7. This is negative. If the value is negative, what happens? You put the first argument first. What's the first argument? 7. And the second argument is 3. And can you see? Oh, sorry, I updated it at the wrong place. This is negative. So the first argument is 7. Second argument is 3. And can you see? In both of the cases of y minus x, we are arranging the data in decreasing order. Can I say that? So that's how the algorithm of sort in JavaScript works, that you have to pass an extra comparator callback. Like this is going to compare each and every element. Right? A question might come to your head is that, do we not need to define x and y? No. It's same as how map works in JavaScript, how for each works in JavaScript, because the implementation of this callback is written inside. You just have to pass the callback, and how the callback is being called, what is the value passed to this callback, all of that is going to be managed by the sort function. Okay? So moral of the story again, if the callback returns a negative value, whatever is your first argument will be put first in the array, and then the second argument. If your callback returns a positive value, then your second argument will be put first in the array, and then the first argument. That's how sorting works. And that's what we are going to do here as well. We are going to pass a callback because we want to arrange it in ascending order, x comma y, x minus y, and we are going to return the result. If you run this code, okay, if you run this code, this works. If you submit, you can see this is accepted. But what we are doing is, we are taking too many instructions. The first problem is that we are taking too many instructions. Apart from that, we are even taking an extra array. So let's say if you try to remove this extra array and update the nums array in itself. So let's say if you do nums at I, is equals to nums at I square. And then you try to sort the nums array only and return the nums array only. So you can see now in this case what is happening. I'm not taking an extra array or extra load on the memory. If you run this code, you can see this is still accepted and submit. You can see this will be also submitted. But again, the same problem that although now we are not taking an extra space altogether, we are just updating the same elements in the nums array and then sorting it. But still sorting is going to take too many instructions for us. We can solve this question in lesser number of instructions. Are you guys able to get this coding solution and understand what's actually going on here? Make sense? Everybody understood how sorting function is working? Everybody understood how sorting is working? We discussed all the 4 possible cases, right? I'll push this code so that you guys can also see it on your machine.